Welcome back to the Game Blocks tutorials. This tutorial covers physics. So what I'm going to do is just try to talk about the physics engine in general, and in different videos talk about specific game types. There is a video for a platformer game where you use physics to create gravity during the jumps. So check that out if that's your main interest. This one will basically get us halfway through creating a space shooter. But then I'll probably finish that out in a separate video. So first of all, the thing with the physics engine, just like the cartoon engine, it has a loop that gets created, something that runs in the background that runs all of the math, and you can see it referred to here. So when you call a physics command, you have to pass this loop in to every different command. And this is a somewhat unfortunate bit of complexity, but it's what had to be done to make it perform in a decent way, and also to work around some kind of really gnarly bugs deep down in the old Scratch code, as I understand it, related to very complicated data structures. So if there's a way I could have hidden some of this stuff, but if you have deep data structures where you're storing scripts inside nested lists and things like that, you run into some trouble. So anyway, this solves a few problems. And so you create a variable, you go to make a variable, probably do for all sprites, so you can be setting the parameters of the physics of the sprite from anywhere, and name it what I've named it over here, physics loop for alien, physics loop for ship. So it's already there. We'll just go ahead and use it. And so first we need to initialize the physics loop. So in motion you'll see a ton of physics blocks, a lot to figure out and sift through. We're just going to start with make a physics loop. So we'll need that. But what we need to do, see, it's a round one. We can't just execute it. We need to set the variable we have to that, so we can refer to it from here on out. So plunk that in there, and we're going to set physics loop for ship to that. And this is a space shooter, so one of the things, this is not really a core part of most physics engines, but this one has a convenient way to set up thrusting. And the way you get thrusting to work is you basically pass in a command it should use to decide whether to thrust. So let's see. Set thrust force. Well, since we see this here, let's go ahead and set ourselves a thrust force. So set thrust force of. The of is always referring to the ship itself. I'm going to go ahead and grab the other one while we're here to save time. We'll set the condition to, and then we'll set the condition of our loop to, and then we'll put the condition there. So let's see. Go back to variables, physics loop for ship. Put this into both spots. There we go. Start so as you can see. And so we'll be doing a thrust force of 0.4. And so it's kind of voodoo. I think this is actually in pixels per frame. So if you're holding the key down, it'll move you but just less than half a pixel. Well, it'll increase your velocity basically at 0.4 pixels per second, or sorry, per frame. Something like that. You just have to tinker with the numbers to get something that that works right. So here's the condition that will be executed when to find out if the ship should be thrusting, and that can be anything really, but it should be probably a key press. So we'll go to the sensing section and get this diamond says key such and such pressed, and space is fine. Now, as in all the blocks that take a condition, we don't want to go in cleanly like this with no border around it. What this means is it'll execute instantly. When you get to this command, it'll end up passing in true or false instead of this actual condition. We want it to save that piece of code and use it later. So to do that, you just kind of have to watch this, whether this border is shown up or not when you're dragging it in. So if you see, it's not going to get a gray border here, but here when you see the gray border pop around it, it will. So now we're passing it in correctly. And this is all you have to do to set up thrusting, basically. We haven't set where you can turn the ship yet, but we can thrust. So let's just go ahead and run it just for kicks. So there I am. If I press spacebar, there we go. I'm thrusting. I'm also wrapping around the screen because I've got some code for that. We didn't set that up, but so that's the idea. Drag is already in there. There's a default drag value for the game system. We'll look at tweaking that in just a second. But let's just keep going to get this basic thing set up for a kind of a space fly around game. I'm going to put a broadcast here. This is just, since this initialization takes a little while, it does take a couple seconds, even on a fast computer. I need to let the rest of the code know, you need to let the rest of the code know that the game's ready to go. So you might have a loading screen or something, and then once you are sure that all of your physics objects are working, then you can continue on. So we want to say that the ship physics is initialized. These are messages I've already created. When you do this the first time, you'll go down to New, and you'll type the message to send to your code, let them know the physics is initialized. What I've done is I've chained my initializations. I've initialized this one, then I send a message, and then I start initializing the sprite, or sorry, the alien physics over here. I haven't done enough different objects to know if that's the best way. That way I know when they all get done in order that everything's initialized. Another way would be to increment a counter or something, and wait till the counter is greater than 5 or 10 or something, and then let your code continue on. Personally, I'm not sure what's faster, if you do it in parallel or individually, but individually is the easiest to keep track of. So let's see. So to turn the ship, we want to be able to turn it right, left, and right. The cleanest way is to check whether the key is down forever. So you can do this with a slightly more complicated code where you do a repeat, and inside that you do an if every frame. But this forever if works just fine also. So let's see, we'll need to pass in a condition. Let's get to this. We're going to turn left and turn right. And we do the same thing here, checking a key press. So in this one, notice this one doesn't let you put a gray bar. It's just the way it works. It's one of the base blocks that's part of BYOB, and it just knows to take this and execute it. It's not actually, I don't even think it has an internal block implementation. It's more of a lower level implementation. So it takes that straight, and we're going to do we're doing A and D, I think. This habit of duplicate things. So A will rotate us left, so counterclockwise, and in BYOB, remember up is 0 degrees, right is 90, so it's going clockwise this way, adding degrees, and counterclockwise would go the other way, subtracting degrees. So what we want to do is change our direction. Let's see, should be one that does that. Let me double check. Yeah, it's called turn. Let me go. So turn counterclockwise, and 3 is a pretty good number. So we'll also turn clockwise. And just as a side note, doing physics, the fact that the degrees are a little bit different here. Up is 0, and it's going clockwise instead of counterclockwise like you would in normal math. Kind of messes with your sines and cosines. So if you get into where you want to do your own calculations of angles and stuff, just be aware you might have to switch your sines and cosines, and then kind of play with a negative sign here and there to get things to come out the way you expect. So, little tricky. Okay, so let's see if that works. See, these guys are already live. It's good to wait till everything's initialized. And there we go. Now we can turn and thrust in whatever direction and turn back around. And we're good. So some other things, we'll talk about math in a second when we talk about collision, but once you have this physics engine running, it's live in the background doing its thing, and you talk to it by setting these commands. You're basically setting parameters on the engine, and then when those parameters go in, the loop just starts using them to update position and direction for this guy. So if we give him an acceleration, say there's a solar wind in outer space, we can put this in, and then now we're blowing across the universe, and we have to thrust against it, right? So now you've got this additional movement challenge. So as you see, we've set a parameter on the engine to make it do a different simulation. We can change that solar wind back to 0. So we can type while the engine's running. Okay, and then we should stop, and then we've got drag. Wait, what do we do? Looks like we still have some kind of acceleration. Oh, you know what? I didn't change the vertical acceleration. So there we go. Now we've taken all of that out. So there's no more wind in space. We can change the drag. So the drag, do we have just a drag command pulled out? Looks like we do. So might as well go show how to find these things too. So there should be a set drag. Yeah, set drag of the loop too. So let's see. Okay, let's drag the loop to, let's just set it to 0. So what do you think will happen if we have no drag? Let's see, we gotta execute it. Alright, so now when we thrust, I'll just put a little bit of thrust. Oh, you know what? It's the inverse of what you might think. It's good I'm doing this. Drag is actually a coefficient multiplied by your velocity. So if I do it to 0, it's actually making this go to 0 every frame. But if I do 1, now we'll have infinite well, we have collision already in, so I haven't shown how to set that up. But so now we're just going to keep going and going and going and never stop because there's no friction at all in space, and that's more realistic, isn't it? Kind of doesn't make for a very controllable ship. But okay, so you see how these different blocks affect a sprite. I've shown this in a previous video, but you can just set a velocity of rotation. Let's see what happens if I do that. That's all we need. Now we really can't control our ship. We can still affect it, trying to, I can make it go fast and make it go slow, but I can't any longer control my ship. That's kind of like almost a separate part of the physics calculations. It has rotation. You can set a drag of rotation, so if I do this, it'll gradually slow down. Wow, it slowed down pretty quickly. I wouldn't have thought it would slow down that fast. And so this drag is actually, you know why? Because this drag is also the same thing as coefficient, so I should do 0.98. Let's do that. Alright, 0.98, and then if we set a velocity of rotation, we'll spin for a while, and then the drag will slow it down. Now the one thing that hasn't been done, when I'll get to collision I might mention this, is that it doesn't calculate angular momentum when you collide with something. Partly it's just that's kind of overkill, especially for a writing class, which is these blocks were designed for. We don't necessarily need perfect collisions. And part is that there's kind of a fundamental limitation within BYOB. We don't really know where these blocks are as they're rotated and positioned. We don't quite know enough information to do the angular momentum calculation. I think we could fake it pretty close, but it's not really quite supported. So anyway, that'll be for a later version of the toolkit, perhaps when we move to newer versions of BYOB. So that's the basics. What else was I going to show? I can go very quickly show how to wrap the screen. Maybe I'll probably should save it for the space in, but here's the code. It's just a simple forever loop. This is going every frame. Every frame we're checking if we're too far up or down or left or right, and then going quick to the other side of the screen. So if the x-position is greater than 230, go to negative 225, so way to the other side of the screen. And these numbers, you just have to tweak these per sprite. What I've found is that if you had a big sprite, they're a little different. You can get things stuck. If you're using the wrong numbers, they just don't quite loop as cleanly. So you just kind of have to tinker with it. These are the right numbers for something about this size, so it's a good place to start. Okay, let's see if there's anything else to talk about for physics. I guess the main thing is collision. So let's move on to talking about collision. We'll do that with the alien. I put collision on him. We'll pull it apart and put it back together so you can see how to do it. So yeah, I don't know if it's probably not worth your time for me to actually do this whole setup again. It's the same exact setup we did, setting the physics loop for the alien to make a physics loop. And notice we're starting to do this when we receive the ship physics initialized. Again, this is just how I can know that everything's initialized. I kind of do things one at a time. So then we set the mass of the alien to 5. The base mass for everything is 1. So basically, if you want this to kind of feel heavy and not move as much when you collide with them, you just kind of make, set its mass bigger, which is what we've done. Okay, then once this is initialized, we send out this message saying we're initialized. And that's when the game can begin, basically. So when I receive this message, so it's just same sprite, but still waiting for this message. Then we go ahead and kick off some collisions. So we've basically got 2 types of collisions set up here. I'll show them over here. These are kind of at the top here. There's handle bouncing, basically, and handle collisions. And so you pull these out and build them just like you would other blocks. You get handle collisions of me. I make the point that you need to pass in the loop for the sprite that you're currently scripting inside, and this is again due to the way BYOB / scratch works. It lets us access some properties we need access to in order to handle the calculations and know that we've collided. So basically, you pass in the loop for the sprite you're coding inside. So we're putting collision on this guy, we're coding inside of him, and then you tell it which sprite to be checking. So it's going to look for the collisions with the ship, and when it finds out that we've collided, it'll just handle the collision based on the mass, based on what speed we're moving at. You don't have to worry about any of those details. You have to tell it which 2 sprites we're checking. And then there's a condition here that lets you decide whether it's active or not. So we're just passing in true. I got the true from the operators just right here. And that, making sure that the gray border is on it again. This wouldn't work. This would just evaluate it into some internal value. You want to make sure it's got the border around it. If I can do that. There. So this just means it's always active. In your game, you may actually want to turn it off for some reason. Maybe you've got like a shield mode and asteroids that lets you move through asteroids like the old Atari did, since they probably couldn't do collision, couldn't give you the shield from the arcade version. And so that gives you some logic control and kind of handles things. Down here it's the same kind of thing, a lot more parameters here, but basically handle bouncing of this loop. It looks like it doesn't have to be the loop we're coding inside, probably not. And then from basically the bounds you want to have. You could make a smaller box if you drew a level and had a smaller box in here where the ship couldn't leave. You could define the bounds with the maximum x, minimum x, max y, min y, and same kind of logic. So here's just a test to see if we can turn off the collision of the alien with a condition. So we can actually run that whole test and see how it works. So that's why we were seeing collisions. Now this is not going to be exactly a WoW demo since you've already seen it work, but let's wait till it's all initialized. Okay. So as you can see, you can kind of, oops, I'm pressing the wrong button. Kind of goes the right direction based on how you collide with them. And there we go. Give a little bit of velocity. So that's the idea. Let's go ahead and test if we can turn off the collisions with the walls. So for whatever reason the game decides that collision should no longer be active. I don't know if it actually worked. It's not highlighting, but maybe it works. Let's go see. And there we go. So it's no longer colliding. Notice there's no wrapping on this guy, so now there's no collision with the wall. He's just going to kind of stick down there. And we can of course turn it back on. Oops. Run that, and now the code automatically realizes he's gone through the wall and pushes him back out. So now he's back to business. Okay, so that's collision. That's really all you should have to worry about to make that work. Okay, so if you want to really get down and dirty and use the physics on a frame-by-frame basis in a game with a lot of physical interactions and things changing over time, like how slippery something is or the wind blowing or something like that, um, you'll want to interact with these blocks in a slightly different way, which is slightly more complicated, and that's purely due to performance concerns or performance issues within the block system itself, kind of dating back to the original work on Scratch, as far as I understand from talking to various developers. So it's just something we have to work around. So again, for the writing class I teach, this is certainly way beyond what would be needed for a project. The reason you would dive into something at this level is to create kind of a battle situation or a very dynamic situation where you create content for it. Like one-liners or reactions to the way the overall games has been scored or a major event or that kind of thing. So it's a good exercise for writers to try to make something like that, something dynamic, come alive with content. So there would be reasons to do it, but this does get a little bit advanced, so it would be a little more complicated than a casual user might wanna do. So the way we do basically is to get quick access to the inside of the physics engine. We need to get pointers to the parts of the engine that set values for different states. So you'll notice all these commands work just fine, especially for just initializing a scene or one change, like maybe you turn on a fan and some wind starts to blow and you want to set an acceleration. You can use these commands for that, and it shouldn't be a problem. But if you start doing a lot of things and you want things to work quickly, then you'll want to get these quicker access to those functions. And you can see this process built out in the platformer tutorial as well. I go through the same process, so check that out to see how to use it in a game type. But let's just go ahead and get access to one of these functions. So what we're going to do is we're going to set the mass of this guy so he's much more heavy, so it's harder to bounce around. So to do that, we could use a block that does that. And for that particular change, it wouldn't be too time consuming, I guess. It'd just be maybe a one-time thing. Let's see, where does it set mass? So we could do this. This block right here would do that for us. Might take half a second, might take a second and a half or more on a slower machine. But to do it quickly, we can get there's a way to get the function we want to use. So we're going to use this bubble here. You can see it's something we're going to have to set a variable to because it's not its own command. It's a bubble shape. So we'll go ahead and set a variable to it. We have a temp variable, so we'll use that. So we're going to set temp to this, and we need to tell it what we want. It's defaulting to get velocity, but we'll get set mass. So get from our physics loop for the alien, set mass. Okay, so now we have a pointer to that function, and what we want to do then is to call it at a certain time. So there's a convenience block for that in the toolkit. It just takes one step out of the process of calling a procedure. This is how you'd normally call it in BYOB, and you'd be expected to get the result of the call and do something with it. This is actually pretty sloppy to just ignore the result, but this just makes the syntax a little bit easier. So we will get the temp variable and put it in there. So we're just going to call temp, pass in some arguments. So we would call this something besides temp. We'd call it set physics proc or set mass proc or something. But we'll set the mass to 15. So we're calling a procedure, passing in some arguments. Now I'll get this started to run. So how would you even know what to type in here for a command? How would you know what arguments to pass? Well, that's the unfortunate cryptic thing about this mechanism. You would have to read some documentation, and that is provided by the toolkit. I'll show you that in just a second. So let's see. We're bouncing normally right now. And if we run this bit of code, now the alien should be much heavier. See, so now we can't move him quite as easily. So there you go. So a little bit of monkey business to get that to work, but this will give you quick access to all the different commands if you need it for some reason. And for the documentation, it is located, if you unpack your game blocks library, you go in here at the top level, there's documentation. Let's look at it. I must have it open, so we'll look at it. It tells you, the command, there's jump, tells you which arguments to pass in, and you can just go through this list to find everything. It reviews how to set this up. See, jump takes 4 arguments, and how would you know what these 4 arguments are without some documentation? So anyway, not the greatest, but it at least solves some performance problems for those who need that solution. Final topic, I hope. You'll notice down here there's a bunch of these bubbles to pull out a value from the engine, and you can use this if you want to do your own calculations of collision. If you want to do a calculation of angular momentum or something like that, you could get some of these values. There is a way to set a center on these guys, which would be used as a center of mass. So all the pieces are there for something advanced like angular momentum. But like I said earlier, there's a limitation in BYOB to be able to do that calculation precisely. You'd kind of be guessing on some of the dimensions of the collision. But these two could be a little slow. You might want to do this mechanism. You can use this mechanism to do a get. You can do a get mass here as well. And so if you're doing those kind of frame-by-frame calculations, you'd want to do that. And then instead of these, you'd be using a call, and you'd probably be using the call that lets you do something with the result, which I'll show, and then that should wrap up this video, I do believe. There you go, you'd be using that one. That's it. I wish you luck making sense of all these physics blocks.